Hello and welcome back for lesson 6.2. We are going to learn some new ways that we can use the normal distribution. So we learned about the normal distribution and the empirical rule in lesson 6.1. And the normal distribution tells us that our data kind of follows like this. It's continuous data. So that's something we have to remember. We're dealing with quantitative continuous data. Let's just remind ourselves that quantitative continuous data. And in this lesson, there will be two parts because it's going to be a long lesson. But also, you will definitely want to have Desmos out and open. There will be a link to all the Desmos that I do today that I highly recommend that you save as the normal distribution. Save that name so that you can just keep going back to it because you're going to be using it for the rest of the semester. So the shaded area in the following graph indicates the area to the left. That's what we also have to remember for Desmos is Desmos only takes the area to the left. But the area to the left and the area to the right add to make 1. So that's what we say down here. The area to the right is the probability that x is greater than x equals 1 minus the probability that x is less than x. So to the left is less than this x value on the bottom, and to the right is greater than this x value. And this is a value of a variable. Whatever our variable is that we're talking about. Okay. And values of x always go like a number line, smallest on the left and largest on the right. So it says, remember that the probability of x less than x equals the area to the left of the vertical line through x. Okay, and so we just talked about that. And the quantitative continuous. So let's just draw a few so we can start getting a feel for that. So if the area to the left is 0.0228, and because half would be here, right? This would mark half on the left and half on the right. 0.0228 is much smaller than half. So we know that it's over here. So this is 0.0228. Then the area to the right is 1 minus 0.0228, and that's 0.9772. So let's write that. This area right here is 0.9772. They add to 8. They add to 1. They must add to 1. Okay, so let's try another one. If the area to the left of x is 0.012, then what is the area to the right? So again, we know 0.012 to the left is much smaller than 0.5, 1/2. So, and it's even smaller than 0.0228. So it's going to even be over here a little bit more. So this is going to be 0.012. So this area over here would be 1 minus 0.012. So of course, we're going to get out our calculator and do 1 minus 0.012, and we get 0.988. So the area here is 0.988, and they add to make 1. Okay, so we're going to be using Desmos, like I said, and we're going to use Desmos to find areas under the curve. Now, if you go think back to lesson 6.1 in the empirical rule, we learned some areas, right? We learned particular ones that were a particular standard deviation, one less than the mean or one above the mean. And if you added those together, it was 68% of the data. But what if we're not exactly one standard deviation or exactly 2 standard deviations? We want a way to find those areas under the curve, and Desmos helps us do that using this. My hole is punched through it. So yours should say normal dist, DIS for distribution. And then we would put the mean of our context, whatever we're talking about, and the standard deviation. And we have to make sure that we check the box that says find cumulative. And then we'll put the minimum value that we're looking for in our area and the maximum value, and it's going to return for us the area, okay? If we just want a, we can't find particular probabilities for the normal distribution. We can only find area. So we always have to have either min and max of some sort. So I'm going to show you some different scenarios. So it says the final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. So we're going to describe it just like this down here. Okay. So it says find the probability that a randomly selected student scored more than 65 on the exam. So we are going to write that down here. This is what it looks like when we write other probabilities. So you'll need to show me that the probability that X is greater than 65. That's what we asked for. And so because 65 is above the mean, so we're always going to draw where the mean is. And because 65 is above the mean, I'm going to mark where that is. I think it's fairly close to here. So this would be 65. And we want to know the area greater than 65. So remember, it looks like a number line, so it's always the smallest to the largest, smallest on the left, largest on the right. So I'm going to shade to the right of that because this is the area that I want to know. Okay, so I'm going to go to Desmos, and this is, we're going to do some Desmos together, but I'm going to show you what we would type so you can see it. It would be the normal disk, 63 and 5, because that's our mean standard deviation. We clicked on the find cumulative probability. Our minimum is 65 and our maximum is hard to see, but if you go there and leave it as a space, it'll automatically put for you a positive infinity in the maximum spot because we don't have a value that we're going to limit to out here. It's starting at 65 is the minimum, but our maximum is endless. So it's going to use a positive infinity. And that area is 0.3446 rounded. So 34.6% of the scores will be above 65. Okay, let's look at another one. The probability that a randomly selected student scored less than 58 on the exam. And I didn't put a curve here for you. And this should be B. So let's put a curve. So this says the probability that a student scored less than 58. So this is what it's going to look like with symbols. I'm putting a box around that, less than 58. And of course, I'm going to put my center. So my center is my mean, which we said was 63. But this time 58 is less than 63. So it's over here somewhere. 58, we'll say. And we're looking for this area over here. Okay. So my minimum value this time, I'm endless to the left. So it's hard to read, but it says a negative infinity up to 58. So my minimum is a negative infinity up to 58, and that is 0.1587 rounded. So 15.87% of my students scored less than 58 on the exam. And sometimes we know the area or we know the percentage or percentile that we're looking for, but we want to know the value that goes with that. Like, for instance, for us, for the score on the exam. So in that case, in Desmos, we're going to use the command, it's inverse CDF. So your paper should say inverse CDF. So we want to do the inverse of this, normal dist, given the mean in the standard deviation. Oops. And then it should be the area. So when we're looking at finding the area, the normal distribution, we can go to the left, we can go stuff in the middle, in between, we can go to the right. But when we know the area, we can only give area to the left. So that's something to remember. So let's look at this. It says for each problem or part of a problem, draw a new graph, which we're going to. So it's a shade of the area that corresponds to the 70th percentile. That's what we want to know. So 70th percentile. So if we let K be the 70th percentile, the variable K is located on the x-axis. So it's some value of the score. And the probability of X less than K is the area to the left of K. The 70th percentile K separates the exam scores into those that are the same or lower than K and those that are the same or higher. We want to know 70% of the test scores are the same or lower than K. So since half would be in the middle, that means 70% of the data would be to the right. So this is going to be 70% of the data, and over here would be the other 30% of the data. And we want to know this K. Okay. So, so we're going to type inverse normal distribution, the mean and standard deviation 63 and 5, and we want to know 70%, so 0.7. We want to know that the score on the exam that marks for 70% of the data is below that score. And we came up with 65.6. So let's look at another one. It says, find the score that marks the top 10%. So this question is a little bit different from the last because we want 10% to the right of the K value. So let's draw that. We want to know this 10%. Because I want to know, if I'm a student, I want to know, am I in the top 10% of students where 10% scored better than me, but 90% scored less than me, right? So I have to get those to add to 1. So, but the command in Desmos uses the left area. So we take 100% minus 10% and we get 90% or 0.90 as a decimal in Desmos. So down below, this is what we're going to type in Desmos. Inverse normal distribution of 63 and 5 of 0.9, because we have to put in the 90% that marks the 10% on the right. And that is a score of 69.4. So we could write only 10% of students scored higher than 69.4 on the exam. So let's try this one together. This is where we're going to go to that so that we can do that. The golf scores for a school team were normally distributed with a mean of 68 and a standard deviation of 3. So X is normal with 68 and 3. Find the probability that a randomly selected golfer scored less than 65. Okay, so we're going to mark the 68. And we want to know, this is what you have to tell me, the probability that X is, because it's less than 65. Now with the normal distribution, it doesn't matter if you do a less than or equal to, they read the same in Desmos. So we want to know less than 65. So 65 is going to go here, and we want to know this. Okay. So I would like you to write on your paper what you're going to tell Desmos, and then you're going to tell Desmos this. So it's going to be normal dist 68, 3, and then you're going to do min is going to be a negative infinity, and max is going to be 65. And then we're going to put our answer up here. Okay. Because this is negative infinity up here. Now we know, in reality, we all know that we can't have a negative score on a golf game, right? But that's how we have to tell it in Desmos. So let's go there. So I'm just copying so I can start a new graph for us for this lesson. Okay, so our mean is 68, so I can do that. And then our standard deviation is 3. And we're going to click on the cumulative. And we have a negative infinity up to 65. And there is the probability 0.1587. So there's a 15.87 chance that a golfer would score less than that. Okay. Let's go back to our paper here. 6.1587. Next up says find the probability that a golfer scored between 66 and 70. So it's going to write like this on our symbols. So between, so X is going to be between 66 and 70. So we have to put the inequality. So X is between those. So we're going to find this probability together. Let's drop it. So 66 and 70. So our mean 68 is between there. So we know that we've got our center there. So 68 is going to be somewhere, 66 is going to be somewhere over here, and 70 is going to be somewhere over here. And we are shading this area in between. This is what we want to know. Okay, this is the expectations that I'm looking for. So normal dist, 68,3, and this time our min is 66 and our max is 70. Let's go try that. And 70. Oh, and I didn't show you, this can be shown on the graph. So I'm gonna turn this one off. I'm going to turn this, it looks like it's on, looks like it's a straight line, but make sure you hit your magnifying glass and it will draw the curve. So your curve should match our curve. That's what we just had drawn. I'm going to turn this one off. Let's go turn on the previous one, and that's what we should have had. So it's pretty cool. There's no reason why you can't have the correct thing drawn on your paper because Desmos draws it for you. It's awesome. Okay. So that probability is 0.495. So almost 50% of the golfers score between the 66 and the 70. Okay. So back to our paper. 0.495. So both of those we know an outcome or a score, right? A score in golf, and we want to find the probability of getting that score in golf. Now let's look at the next one. What is the probability that a golfer scoring in the top 15% of his team? What is the probability of a golfer scoring in the top 15% of his team? Top 15%, okay, and we know the percentage, so and it's bigger than 50%, so top 15% means it's over here, so this is going to be 0.15. Okay, and it's not what is the probability, what is the score of a golfer's score in the top 15%. Okay, that's what your paper should say. So we want to know what X will have to be bigger than to be equal to 15%. Okay, so this time, before we were finding the probability out here and we knew the X value, but now we're trying to look for the X value. So this is where we're going to have to tell it, we want to know the X. So we're going to have to do the inverse. Okay. We're going to do this one right here. So the inverse normal. So inverse parenthesis normal dist parentheses, then the mean, the standard deviation, and then a comma. But remember, the comma has to be the left area. So we have to do 1 minus 0.15 to get 0.85. And that's what goes there, 0.85. Okay. Now what's cool is Desmos will let you type 1 minus 0.15 there if you don't know this calculation. So you could just do 1 minus the area on the right. So that's cool. And find this in Desmos. I'm going to go to my, okay. So we are going to do this. We're going to copy that down here. But I have to put inverse in front. Inverse. And comma 0.85 parentheses. Maybe it's because I copied and pasted. Oh, inverse CDF. That's what I didn't do. Inverse CDF. There we go. So make sure I'll correct that for you. And it has it, I just didn't write it. It's inverse CDF. Okay. So that golfer would score a golf score of a 71. Means that he would be in the top 15% of his team. So 71.1 is the X value, but we would probably round that. You can't get a decimal answer for a score in a golf game. So the golf score of 71 would put in the top 15%. So that ends the first part of 6.1 or 6.2 video. Catch me back. We're going to do a bunch of examples in the last half of this lesson video. And have your Desmos out.